human body is like a machine, the most complex and elegant machine known to man. The brain is like the command center, food, the oil, and the organs work together to maintain the whole. The moment just one of these parts fails spells catastrophe for the whole system. I use this analogy to illustrate the fact that the human body, like any other piece of modern technology, is interdependent. Failure of a single component can have dire consequences. Today I will highlight the issues that arise when attempting to replace these parts, or in the case of the human body, replacing organs when they fail to function. This is commonly referred to as an organ transplant. Every year in New Zealand, over 550 people need an organ transplant, but there are only ever around 293 organs available. This means that up to 220 parents, siblings, and children go without the urgent treatment they need. Across the world, this number is much larger, with global waiting lists estimated to be well over 500,000 people, some of whom die without receiving the urgent treatment they need. In the UK alone, 1,000 people die each year while awaiting a transplant. Now, even if there was a way to give everyone on those lists organs, people would still die. This is because of the immunosuppressants given to transplant patients also, to stop their bodies from rejecting the foreign organ, also cause the patient's body to lose its protection against infection. In a study by UpToDate between 1985 and 2015, it found that the median mortality rate 5 years after heart plant was 40%. For perspective, that's about 20 people in this room dead. Now, scientists, despite the best efforts of scientists creating things like cardiac machines or dialysis machines, both of which have saved innumerable lives, of course, nothing compares to the freedom of one's own organs. Considering this, is it a surprise that the international black market for organs is growing, with the World Health Organization estimating that over 10,000 back alley surgeries happen each year, and many of the people involved in these surgeries are there either out of desperation or against their will. Now, New Zealand has created various initiatives in an attempt to increase the number of organs available. Initiatives such as the compensation for live donors, in which a person would receive the average wage for 12 weeks while recovering from a donation. The Quality Improvement Program, which helped doctors working in the ICU better identify possible donors, and of course, adverts, all encouraging people to become registered donors. But despite these campaigns, in 2018, the number of donors went down by 18%. That is, only 62 donors were available for a waiting list of 550. When you consider that New Zealand has a growing, aging population with increasing medical needs, something becomes plainly obvious. If we continue to rely on donated organs, more and more people will suffer and die. But there is a solution waiting to be tapped. In March of this year, scientists at Tel Aviv University successfully printed a small human heart. They achieved this through a process known as bioprinting, the 3D printing of organs from cellular material. To do this, they first took a tissue sample from a patient and separated it into cellular and non-cellular material. The cellular material was introduced to proteins like OCT4 and SOX2, which made it become embryonic stem cells, cells that can be reprogrammed into any other variety of cells. These cells were reprogrammed into endothelial and cardiomyocyte cells, the types of cells that make up a heart. The non-cellular material was processed into a thermoresponsive hydrogel, which when introduced to heat, hardens. After this, the hydrogel and the cardiac cells were then combined, producing two distinct bioinks. These bioinks were then printed from a specialized 3D printer into a gelatin bath, with the gelatin acting as a structural support during the printing process. Once the structure was printed, heat was applied, causing the gelatin to become liquid and wash away, and the hydrogel to harden, creating a full heart. Now, scientists at Tel Aviv are not the only ones who've managed to bioprint organs. labs across the world have managed to print less complex organs, such as bladders, ears, and skin, proving that this is a viable and versatile technology. This technology has the potential to shape medical history, similar to how the first organ transplant by Dr. Joseph Murray in 1954 did. It's in fact, when compared to traditional transplants, surpasses it in three key areas: cost, time, and patient survivability. In terms of cost, bioprinted organs are far cheaper than traditional organs, with the average cost of a bioprinted liver being $15,000, whereas a harvested liver costs around $250,000. And when you account for the anti-rejection drugs transplant patients would require, this price goes up year after year after year. These extremely high costs may explain why so few people can afford transplants outside of Europe and America. Now, bioprinting, in terms of time, a person can expect to be waiting for months or even years to get a transplant, whereas the average amount of time it takes to bioprint an organ is 8 weeks. Picture this: a lab, perhaps in Wellington, with just 100 bioprinters, each printer printing at a rate of 8 weeks. With 52 weeks in a year, this lab would produce 650 organs annually, surpassing current demand and providing a rejection-proof solution for every Kiwi in need. And in terms of patient survivability, one of the main downsides of organ transplants is that when implanted into a patient's body, their body rejects the foreign organs. As shown by this graph, the likelihood of the mortality rate after a transplant goes up every year. This wouldn't occur were bioprinting used, as the organs are made from a patient's own cells. The patient survival rates would greatly increase, saving the lives of every one of your loved ones and my loved ones that needs an organ. But the lives of our loved ones are not the only benefit to New Zealand. Bioprinting also offers various economic benefits. It would guarantee New Zealand firms profit, as they would be able to fill the increasing global demand for organs at a fraction of the cost of harvested organs. Jobs would be created, as this is a technology with potential uses in many areas, and government spending would be reduced, namely the spending on the immunosuppressants required by transplant patients. That's a reduction from the 112 million spent annually. In terms of the environment, bioprinting, when compared to other organ alternatives, which tend to be made from plastics, has far less of an impact, as it's biodegradable. Also, when compared to traditional organ transplants, bioprinting is far more environmentally friendly, as traditional transplants impact the environment through the immunosuppressants that pass through transplant patients as waste and enter our waterways. Studies in America and India have found that pharmaceuticals in waterways are at an all-time high. This is not something we would want happening in New Zealand, negatively impacting our ecosystem. Altogether, this makes bioprinting far more in line with New Zealand's green image. And socially, bioprinting has the potential to benefit New Zealand communities. Many of the deaths that occur in New Zealand are due to organ failure. Were this technology available, we could combat that, giving Kiwi families more time together. It would also greatly benefit key New Zealand ethnic groups, which are disproportionately represented. In a study conducted by the New Zealand Medical Journal, it was discovered that 47% of those on pre-transplant treatment were of Maori or Pacifica descent, with Maori being 50% more likely to die while being treated. It would also improve the lives of those who wouldn't necessarily be considered for organ transplants, like the 26,000 diabetics who suffer from a defect in their pancreas. We could eliminate this issue by simply printing diabetics a working pancreas, freeing their lives so they don't have to keep constant watch over their sugar levels. In terms of ethics, bioprinting could be used to replace the 250,000 animals used in lab testing annually in New Zealand, providing far more humane, and in the case of clinical testing, accurate results. And on the same vein of thinking, they could be used to replace volunteers in drug trials, reducing the risk to their lives. Bioprinting also has the added ethical benefit in that it could give people access to treatments that they wouldn't have otherwise been able to afford. Organ transplants cost a lot of money. If New Zealand were to pursue this technology, it could potentially provide it at an affordable cost, similar to how Fred Hollows, an amazing New Zealand philanthropist, gave people across the world access to affordable lenses, curing their cataracts and saving their sight. In conclusion, bioprinting offers a solution to the growing global problem of increasing organ demand. It would save the lives of not only people in New Zealand, but the lives of people across the world. It has the if pursued, New Zealand could become a world leader, improving not only its economy, but the well-being of its people. And just before I finish, I would like to encourage all of you here, if you haven't already, to become an organ donor, because the reality is developing technologies like this takes time. And until it is ready, the only way to save people's lives is through the goodwill and generosity of people like you. Thank you.
Thank you, Allan. What's in the jar?
Oh, it's a deer heart.
Joy.
Yeah. My teacher who helped me make the speech does a lot of hunting, so he brought this from his home and put in some methanol for me to show all of you.
Handy, yes. Have the Israelis coped with what's called the vascularization problem, which is that it's relatively simple to create an organ, but it still needs a blood supply to work? Have they done that?
I'm afraid I haven't really heard of this issue before, so I don't have an answer for it.
So we don't know at this point how well the bioprinted organ actually works.
Actually, there is a case in Boston, America, where a scientist printed a bladder for a young child who didn't have a working bladder, and they implanted it into that child, and it worked fine. That child has never had to go to the doctor again for any issues.
Animals or people will still be needed for trials of the bioprinted organs, will they not?
Of course, I mean, no technologies like this can go through without testing on people.
No, I just wondered how you advertise it as needing fewer animals or people to be tested.
If there were ever a stage when these technologies were perfected, we could use them to replace animals in testing, because when we do clinical trials, we test the effects that those chemicals would have on human bodies or specific organs. So we could print organs and then test the chemicals on those organs without risking a person's life or health.
Do you know how they keep the cells alive as the organ is bioprinted over that period of time?
I'm pretty sure the gelatin bath in which the organ is printed in has some particular chemicals in it which keep the organ alive during the printing process. But afterwards, it would have to be stored as a normal organ would, were it taken from a person.
Thank you.
Thank you.